So where were we in our wave optics?
Ma?
Yes, how much we have completed in wave optics? I think we have seen this question, right? Of diffraction. Yes, Hemant, please do reply.
Yes, sir. We have completed this question.
Yes. So, okay, fine. Now let us move ahead. Now see this question, next question. Write down this question. Light of a wavelength of 6328 angstrom is incident normally on a slit. Means light is perpendicular on a slit. See, on a slit is written, means slit is single. It means the question is of diffraction. You must understand that. The question is of diffraction. Okay. Width 0.2 mm is given. Calculate angular width of central maxima on a screen at a distance of 9 meters. Calculate it fast. Yes, now you got the question?
Sir, board, sir, 1.
Yes, any answer? Hemant.
So we can say 0.9, we can say 0.36, we can say also.
0.36 degrees is the answer. See, nothing you need to do in this question. Just you need to put all the things in formula, that's it. We know width of central bright, 2 lambda by A. So what will be the angle?
So it's 60 to 80 into, we can say 10 power minus 10 megabyte.
That is the answer. Fine. Now see this next question fast. Try to solve it in little bit less time. Find half angular width of central bright maxima in Fraunhofer diffraction pattern. Fraunhofer diffraction pattern is the same diffraction which we have seen. Single slit diffraction is Fraunhofer's diffraction. Of a slit of width 12 into 10 to the power minus 5 centimeter. When the slit is illuminated by monochromatic light of wavelength lambda 6000 is given. Lambda is given, width of slit is given. What we need to find? We need to find half of the central bright. Half of the central bright, that we need to find. Okay. It means you need to apply the formula of central maxima.
So we can say it's 30, we can say half the angle.
Yes, what is the answer?
So it's 30, we can say 30.
Fine. How did you solve it?
So we can directly say that half.
Yes, very good. It is 2 lambda by
2 lambda by A. Half means lambda by A, we can write.
half means lambda by A, and lambda by A is given the 0.5.
Yes.
So this is angular displacement. Means angle which is at the center is 0.5. Angle which is forming at half of the center, that is 0.5.
Yes.
Sine theta of 0.5 is 30 degrees. That's why we are getting theta to be 30. Now see this question. Good question. A slit of width A is illuminated by light of wavelength is given here. At normal incidence, find the width of slit when first minima fall at the angle of diffraction of 30 degrees. position of first minima is given. In fact, the first minima falls at an angle of diffraction of 30°. First maxima falls, first minima falls. There is difference. Okay. Try solving. Yes, did you get any answer?
Then now it is correct. When is the 1.25 and the first point angular and the theory.
Okay. First part is what? What did you say?
So 1.25 we can say.
1.3 is the answer. Just we need to calculate A. We need to calculate A. What do we have? We have wavelength, nanometers. Okay. And what do we have? Wavelength we have, and angle we are also having. What is sine 30 degree? 0.5. So 0.5 equals to lambda by A. 0.5 equals to lambda by A, that we know. Okay, from here we are getting our answer. Next is, first maxima falls on at the angle of diffraction of 30 degree. Now what is the angle of diffraction? Angle of diffraction for maxima, that is odd multiple of lambda by A, means lambda by 2. Odd multiple means what? Odd multiple means what? Odd multiple 2n plus 1 by.
Yes, 2n plus 1.
Fine. So when we put n equals to 1, that will become 3. So it will be 3 lambda by 2. 3 lambda by 2. That we need to calculate, and we shall get our answer. Get it now?
Yes, sir.
Getting it now?
Yes, I get it. It's a population one.
Now next one is resolving power. Now what is this resolving power? Resolving power is ability to differentiate between two objects clearly. Like our eye is there. Have you ever sat at the last bench in your classroom?
Yes, sir.
Now, from the last bench, were you able to see everything clearly, each and every point clearly? No. There was a limit. 2 points which are drawn very, very close to one another. From far, this seems to be one, is it not?
Yes, sir.
Even after a person's eyesight is fine, 6 by 6 eye lens is there. Health of eye is perfectly good. Even for that person, the two dots which are drawn very close to one another, they will appear as if they are single dot. But ultimately, when we go close, there will be difference between them. So this is happening. This diagram I have drawn is two dots which are drawn at very, very close distance. But when we are seeing from near distance, means nearby, we are standing, then the waves are coming clearly. Two different waves are coming from two different sources. But when we move far, what will happen? Waves between them will start interfering with one another due to diffraction. This is called a diffraction, bending of the light rays. Bending of the light rays. And why is this happening? Because the distance between the two objects is very, very small as compared to the distance at which we are situated. Because of that, the 2 points will appear to be one. And if we go more farther, what will happen? The two rays of light will completely overlap each other, and we will see only a single point. So what is this resolving power? It is actually ability of eye to separate both of them. Separation means what? Separation means angular separation. So smallest angular separation at which the 2 point objects are distinct, that is called resolving power. at least this much angle must be formed. That is called limit of resolution, that angle. And resolving power is defined as reciprocal of this smallest angular separation. Reciprocal of this smallest angular separation to see two objects distinctly. Take it down now.
So competition.
Fine. This was dependent on Rayleigh's criterion. That images of this is what we have seen, means we have understood just now. Images of two objects are resolved when central maxima of the diffraction pattern falls over the first minima of the diffraction pattern of the other. Getting it? Means maxima must not combine with one another. If maxima of first is combined with the maxima of second, the images will appear as one.
Say that, sir.
Done? Now next is we are moving ahead to human eye. Now optical instruments, we are moving on optical instruments. Now what is human eye? What is the resolution for a human eye? What is a human eye that we have already seen in ray optics? Now the thing is about resolution. What is the resolution of human eye? So for human eye, angular resolution is 1.22 lambda by d. Okay, this part is important from board's point of view alone. Okay, JE has not asked this question, but they also have not deleted it yet. Okay, from wave optics. So it is a part of diffraction only actually. So for human eye, angular resolution is 1.22 lambda by d. Lambda is the wavelength and d is what? D is the diameter of pupil of our eye. Pupil is the hole from which the light is entering our eye. That is 5 millimeters broad in diameter. Okay. So what will be the average wavelength? Average wavelength is of a natural light, sunlight. Its average wavelength is 550 nanometers. So divide both of them. 1.22 lambda by d. We will get our answer. And the answer is what? Answer is answer is coming out to be 0.5 inches. Means not even 1 degree. After 1 degree, 1 degree is further divided into 60 inches. And in that also, 0.5 inches is the angle. Means if 2 points or 2 objects are making an angle smaller to this distance, then our eye will not be able to identify them as 2 different objects. Okay?
Okay, sir.
Taken down?
Taken.
Like for example, in night sky there are several asterisms. Asterisms, you know, nakshatra. Yes, asterisms, you know. Hello.
Sir, go on.
Hello.
Hello.
Am I audible?
Sir, you are audible.
Yes, I am saying asterisms. You know what are asterisms? They are nakshatra.
Sir,
Asterism.
Aster.
Yeah. asterism is called nakshatra. Like in India, they are called by different names, and in Europe they are called by different names, like Aldebaran, Kritika nakshatra. One nakshatra is called Kritika nakshatra in
Yes,
India.
sir. Kritika nakshatra.
Yeah, that Kritika nakshatra, we see it as a single star. But ancient Indian astronomers, they have written that Kritika got rebirth as sister, as means four sisters. So there are four Kritikas and four sisters, four or six. A little bit confusing. Either four or six it is mentioned. But when we see it from a very, very high definition telescope, we come to know that Kritika Nakshatra is actually not a single star in any way. This Kritika Nakshatra is actually a group of galaxies and several stars. Group of galaxies it is. So several stars are there, hundreds of stars are there, and those galaxies are they are seen as this Kritika Nakshatra. With our naked eye, we can only see that Kritika Nakshatra is a single star. And very light dot, in form of very light dot, it is visible in the sky, Kritika Nakshatra. This Kritika Nakshatra means the month of Kartik is going down right now. And on the full moon day of this month, this Kritika Nakshatra was along with moon. Means moon was along with this Kritika Nakshatra on full moon day. That's why this month was called Kartik. So thing is that Kritika Nakshatra is consisting of several galaxies, several stars, but they all are making an angle less than 0.5 inches with our human eye. Hence, our naked eye cannot differentiate between these two stars. Getting it? The angle is very, 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 very less. Got it?
It's a code.
Now, again, always remember this: 1 degree is divided into 60 minutes, and this 1 inch is divided into 60 seconds. And strangely, astonishingly, just for knowledge, I am telling you that this division of degree into inches, into minutes, degree into minutes, and minutes into seconds, this also originated in ancient India. There is a book again of astronomy, and it is used in astrology. The name of that book is Surya Siddhant. It was written by some Mayadanav. It is said that he wrote that book. And in that book, he has given this same classification of one full circle, dividing one full circle into 360 parts, and each part further divided into 60, and then again each part further divided into 60. That exact same is given in that book, Surya Siddhant.
Yes, sir.
And he gave it as different name he gave it to them. Degree he called, like degrees there, he called it Ansh. And this minute he called them Kala. And then seconds he called them Vikala. So all of it is actually given in Surya Siddhant. It is said to be written by some Mayadanav. He was one of the friends of Pandavas. Okay, then that's all just for knowledge. Now let us come upon microscope. What is a microscope? See, resolving power of microscope is 2 mu sine beta by 1.22 lambda. 2 mu sine beta by 1.22 lambda. Now what is this angle beta? This angle beta is half angle. Half angle means this is the angle. This is the chip, and in this glass chip we are seeing is this small amoeba or onion peels there. Okay, so whatever angle it is making with the lens, half of that angle, beta, that beta angle is taken here. 2 mu, mu is the refractive index we already know. Sine beta, the sine of half angle, upon 1.22 lambda. 2 mu sine beta by 1.22 lambda. This is the resolving power for microscope. And similarly for telescope, the resolving power is d by 1.22 lambda. That's it. D is what? Diameter of objective lens. It is not distance. It is diameter of objective lens upon 1.22 lambda. Please take it down. There is nothing to understand in it. Just you need to memorize it. That's it. Copy till there. Next is now important topic is polarization. What is polarization? Again, this polarization is actually because light is vibrating. Light is vibrating sinusoidally. Light produces because of vibration of electrons. Is it not, Hemant? Hello? Yeah,
Yes. So you're on.
yeah. Light is produced because of vibration of electron. Now, electron can vibrate in any direction. Getting it? Electron can vibrate in any direction. It can vibrate here. It can vibrate here. It can vibrate here, here, here. Anywhere it can vibrate. But there are some crystals. Those crystals were first of all discovered in ancient Sri Lanka and Tamil Nadu. In Tamil language, that crystal's name is Tuvar Malli. That is a Tamil name. That Tuvar Malli, when it came in contact with the Europeans, they named it tourmaline crystal. That is nothing but coming out from this Tuvar Malli crystal. That tourmaline crystal, it has a property. What properties it has? It acts as a filter. It acts as a filter for light ray. See, I have shown that this light here, it is having both the vibrations in perpendicular direction, like this white one and this red one. Okay, both planes are perpendicular to one another. So when this light is incident on this polarizer, what will happen? It is like the bars of a jail. Only that part will be able to pass which is vertical. All the rest of the parts will be obstructed. So only this white ray will be allowed to pass through it. Getting it? This tourmaline crystal appears naturally like this, deep inside Earth. Got it? In Sanskrit, this tourmaline is called Vaikrant Mani, and this mineral was present in ancient India since very ancient days. And this Vaikrant Mani or tourmaline, it has the property to allow only plane polarized light to pass through it. Means light rays which are vibrating in a single plane will be allowed to pass. Light rays in a single plane will be allowed to pass. Like see this. Electron is vibrating in every direction. Means what? Vibration is like this. It is like this, okay? Which we are seeing. It is like this. But when we put a polarizer, only single type of vibrations are coming out. Obviously, the intensity will be decreased because of polarizer, but light will be plane. How it is discovered? How it was discovered? It was discovered through again this tourmaline or tourmaline crystal. This tourmaline crystal is actually transparent crystal. But when we see sky, we can only see the blue color at a particular angle. If we rotate it, this blue color disappears and the crystal appears to be black. If we rotate it, the crystal appears to be black. And if we align it, the crystal appears to be transparent. This is the property of this Tourmaline crystal. It means what? It means two things are there. Light coming from the sky, blue light, is a plane polarized light. Plane polarized light means whatever blue light we are seeing, that blue light is in same plane. Like this is the sky, this is the blue light. Okay, so this is plane polarized light. Light rays are vibrating in same planes. Okay, that is polarization. Write down the polarity property like polarization can be exhibited first of all only by transverse waves. So this is the second thing. Light rays are transverse, and another thing we have studied just now, that waves, light coming from the sky is plane polarized. Now again, what is happening? It is sinusoidal, but the electric field vector of light wave in a plane polarized light always lie in a single plane. In a single plane. This is a plain piece of paper. This light is always there in single plane. Okay. What is happening actually? When unpolarized light is passed through a polarizer, the resulting light is called plane polarized light. Tourmaline crystal, Nicol prism, and Polaroid, etc. They are the examples of some polarizers. And the plane in which the vibrations of light vector, and direction of propagation lie, that is called plane of vibration. Take it down till this point. Taken it? Okay then. Next is polarization by reflection, and from here we shall see in our next class.
Yes. Thank you, sir.